the electrical grid cannot handle the demand for required to charge EVs.
Yeah.
So there's a lot of assumptions there in that one.
Yeah, so let's try to give this some validity because I don't want to just dismiss these comments. So it assumes it's making an assumption. Let's say that everyone in the world, if we could snap our fingers, every car in the world, I think there's about 1 billion cars in the world, uh, were to be electric, and that all those cars, everyone goes home at 5:30 and plugs it into their DC fast charger. Yeah, that's going to cause obviously a drain on an entire system, and you're going to get blackouts.
So would it be if everyone went home and turned on their electric dryer or their
We saw that.
range to cook dinner,
We saw that in
air
California.
conditioning in the hot, in the hot weather causing brownouts? So
We just saw
we
that
already
in
have demands
California.
on our system, right?
Yeah, we just saw that. It that doesn't stop technology. So when air conditioning came out, I think it was in the late 40s, 50s, when air conditioning, nobody talked about, oh, it's going to cause the grid to collapse. That never happened. So first off, that scenario is unlikely. So it's going to be slow and gradual that we're going to more and more people will switch to EVs. So we have to increase our total output, and we're doing so at about 4% a year. So if you measure what the output was in 1960 to what it is now, it's probably increased about 4% a year, right? So we're producing much more electricity to meet all those demands, and we're just finding new and innovative ways of doing that. Now, it has been estimated that once we hit that 100% all electric vehicles, no gas on the road, that will probably mean an increase of about 30% of the total hour energy output that we will need. So at 4% a year, it's not going to take that long to hit the 30%. And that's probably will exceed the actual growth of EVs. And then there's a second component to that as well, and this gets back into the battery storage. So it's often a case that you can produce lots of electricity at certain peak periods of time. Um, and what you do with that excess electricity? Well, this is where the secondary battery storage comes in, and so that's going to even out the grid. So there won't be those high demands placed on by plugging in your EV overnight. That's going to collapse the system, right? Because if the energy if it's from renewables, if the sun's not shining or the wind's not blowing, it relies on the backup battery storage, and that's why batteries are not going to end up in landfills, right? Because we can use them, remanufacture them, and then every household could have a backup battery storage, which is very, very likely. It's already happening. We're already seeing that. Tesla's invested heavily into their batteries, and other companies are starting to come up.
Welcome to EV Friendly. This is the podcast for you if you're interested in engaging conversation about electric vehicles. We're switching things up a little bit this time. On this episode, I'll be your host. My name is Renee Young, and your regular host, Ken Hendricks, will be the guest. We're going to discuss some of the myths and misinformation that you'll often see on social media about electric vehicles. Ken is the senior advisor for the Automotive Retailers Association of BC, and he spearheaded the EV-Friendly Program, which is a multifaceted program addressing the government of BC's mandate that by 2035, all new vehicle sales in British Columbia have to be zero emissions. So Ken, welcome to the podcast.
Thank you, Renee.
And why don't we begin by getting you to tell us a little bit about yourself, your background, and how the EV-Friendly Program came to be.
Sure thing. Well, I say I'm a third generation automotive industry and third generation with the Automotive Retailers Association, which sort of powers the EV-Friendly Program. So my grandpa Myers came from Saskatchewan years ago as a mechanic, and he ended up opening up a couple Ford dealerships on the island. And then my father, Ed Hendricks, began working with him and went through the Ford and he ended up becoming president of the ARA. And then I guess it was just a natural progression. Family business just took over, and I became an advisor in with the ARA. And it was probably about 5 years ago that I began thinking about electric vehicles, and really at a time when I don't think anyone else really in the automotive aftermarket services industry, and what I mean by that is sort of anything that happens to that vehicle after it's been sold. It runs through a complete life cycle. Nobody was talking about it. Nobody was thinking about it. And it wasn't even really much in the press at that time, but I sort of picked up on that, and I thought, this is going to be a transformative technology, and we need to be in the ground floor of this. And if we're going to hit these environmental targets, and it was sort of at that time that the government had come out with its more aggressive. At first, it was 2040, which I thought was quite aggressive at that time, and then they reduced it down to 2035. If we're going to meet those targets, they're going to have to start thinking more than just incentives on new vehicles. They have to consider the whole life cycle of that vehicle, and that's really the only way that we're going to build consumer confidence. We still have a long ways to go. BC has come out way ahead of this whole EV space. We're leaders in all of North America, not only just in uptake, but in the government support. And one of these programs, which is the EV-friendly program, which is designed to educate and instill confidence in consumers.
Yeah, and so the EV-friendly program addresses the government or assists the government in its mandate by recognizing that the industry needs to be trained in order to be able to handle safely and efficiently electric vehicles. And so you've developed all these training programs that are online, and companies that do participate can become EV-friendly certified.
Yep.
And you know, so this is the missing link in the chain, because at the time of the mandate, they basically all they had was incentives for the purchase of the new vehicles, not even used. That's
right.
Changed now.
It
but
has.
you know, they hadn't given any thought to what happens. Okay, what if you're successful and a lot of people do buy electric vehicles? You know, who's going to look after them? And
Yeah,
so that's what the program.
And people have legitimate concerns that weren't being addressed. This was new technology. They didn't understand it. They couldn't, and still, I don't think a lot of people could really describe when they get into their electric vehicle that they know how it works. And I think we have a pretty good intuitive grasp on a gasoline-powered vehicle, an internal combustion engine. And I think if you ask anyone on the street, what makes your car go? They might be hesitant at first, but if you press them, yeah, I get in and I turn the ignition and spark plugs ignite some gas and it pushes a piston down and so on and so forth. They have a basic understanding of that. And anyone who's been driving long enough, you know what it means to break down on the side of the road and, hey, I ran out of gas, or you can tinker around with your car. It's just not so with electric vehicles. And so there was just a lot of concerns. Are they safe? Was a concern. What happens to the battery? You know, are they environmentally friendly? Are they cost effective? These were all legitimate concerns that we wanted to address. And the best way to do that was going to educate industry. Industries had 100 years of fixing gas-powered vehicles. We've become very, very good at it. But that infrastructure that we built over that 100-year period just does not instantly transfer over to EVs. We have to begin building a new infrastructure with new skill sets, new training. And that's all what the EV-friendly is designed to do. And so it, as a program, offers industry the tools and resources it needs. And that's from training to the higher level business certification, which is called the EV-friendly.
And another facet of the program is, of course, in educating the consumer and addressing some of the common misconceptions that are out there and the misinformation that's out there.
There's a lot of that.
So this series of podcasts is one example of how we've not only been educating the industry, but there's been information for the consumers. However, you still have the skeptics out there, and every time there's a news announcement or something that's pro EVs or about a new government program, or they want to invest in this or that to do with EVs, there's always the naysayers that proliferate on the social media platforms and their comments. We've got a few of them here that we have picked up on.
And they're okay. It's okay to be a skeptic. It's okay to question it, and just not accept things blindly. That's what we're here for, is to answer questions. We just want to do it honestly and give the best information. We're not here to sell anyone an electric vehicle. We don't make here at EV Friendly, we don't make EVs, we don't sell them, we don't service them. We just help people with the transition.
Right. Well, so some of the Facebook comments that we've picked up on, I'll just read a few of them here. Some of them are, genuinely, are genuine, legitimate concerns. Others are just right out there in the field.
We get a lot of them on the EV Friendly
So
channels,
you hear things like, "I'll never touch an EV as long as I live, LOL. They're plain and simply junk. Can we stop calling electric vehicles zero emissions and start calling them supreme polluters like they are?" And then here's one about towing. Yes, most tow trucks are diesel powered. Tow truck operators should charge double for handling dangerous electric vehicles that could erupt into flames if involved in a collision. One problem with EVs is when they erupt in flames, it won't go out until the battery is dead.
Okay, that's the first. I have never heard of that.
Gas or diesel vehicles can be put out with foam.
No, false.
Okay. EV is the biggest con job on the hardworking families and that they're financially struggling. I cannot believe the government is pushing everyone to get in debt for this plastic junk. EVs are a scam on the weak-minded, and the only way it works is if there are way less people. Well, that's just a random sampling. So let's dive into some of the actual concerns.
I've heard that last comment. That's actually an interesting.
Yeah, there's some common themes there. So we've captured what we think are some of the most common misconceptions, myths, or outright misinformation that's out there. So
those were from our Facebook channels?
A lot of them were, actually, yes. So yes, you can follow EV Friendly on Facebook if you want to see more of those.
Facebook and YouTube, and Instagram and Twitter. So we're on all the channels.
So let's deal with some of these one by one. So the first one we have here is EVs are all part of a government WEF conspiracy.
Oh, I like that one. So WEF stands for World Economic Forum. A conspiracy, hardly a conspiracy when the agenda is made known. So once a year, leaders from around the world meet with these forums. They discuss high-level concepts like the economy and the environment. Most of it is out in the open. You could go to the website and read what they're talking about. There's some closed-door sessions and stuff. I know that the WEF, you hear about it in sort of the mainstream media and dialogue, and there's a lot of skepticism. I think it's right to question what some of these institutions are doing. I think that's actually healthy. But hardly a conspiracy. So, because it's known. And furthermore, these mandates that the governments have come out with have passed through a legislative process, right? It's been voted on. It's had the cooperation of not only legislator, but of stakeholders, of manufacturers. It'd be pretty tough to get all these people in a room and, hey, let's all coordinate this underhandedly. Probably not likely. Now, you may not like the outcomes, you may not like the ideas that are being expressed, but it's hardly a conspiracy. It's all out in the open.
Yeah, well, if you reverse engineer most conspiracy theories and, try and establish, first of all, what is the mandate? Who stands to gain by doing this? And how would they get there? Like, faking the moon landing, for example, and all the thousands of people that would have been involved, and none of them had spoken up in more than 50 years, Anyway, I agree with you on that one. Here's another one. EVs are a fad, just like other alternative fuels that have been in the past.
Okay, well that's a fair question. It's not really a question. It's more
because natural gas never took off. I mean, they are in some commercial applications, but at one time it was touted to be one of the big
It
answers
it
for
it
vehicle emissions.
was in the 90s. There's a lot of hope in around propane and natural gas in the 90s, and in fact, the ARA, the Automotive Retailer Associate, actually had an entire division dedicated called the Alternative Fuels Division, and there was a lot of hope in with that. I think later on, biofuels came out. You remember biodiesel was all the rage in around 2005, in around that time. These didn't work for a lot of various reasons. They never really quite went away. They're not gone. They're actually still around. Natural gas is still with us. Biodiesel to a very limited. They really realized that harvesting crops for diesel was actually causing more damage because it's much better off to go for food than it is going to go for fuel. But they're still around. In fact, in some ways, they may be making a comeback. And I've been hearing more and more about this talk. And the reason is because it is recognized that even with the accelerated growth of EVs, with the mandates, even at that 2035 point, only 50% of the cars on the road will be electric. There will still be 50% of those running on petroleum. And so the thinking is, well, let's bring back more natural gas. Let's start incenting those things. Because yes, eventually electric vehicles in 30, 40 years, everything will be electric. But let's wean ourselves off as much as possible, and maybe natural gas and propane can provide some alternatives. So it's still around.
Yeah, but as far as EVs just being a fad, none of those were. Well, I guess in some you could make an argument that they were a fad, but they probably fizzled out for other reasons. They weren't just the popular thing of the day.
There was, so maybe 10 years ago you could make that comment when they were just in their infancy. A few people had a vision. Certainly someone like Elon Musk had a vision with EVs well before it caught the attention of anyone in government or other manufacturers. He certainly wouldn't have subscribed to that. And that's generally what it takes. It's just somebody with a vision driving it. I don't think you can say that now. There's just too much momentum behind this. Not only does it just have the support of the government, look at what manufacturers are doing now. There's not one manufacturer, unless they're very specialized in a particular vehicle, that is not opening up their production lines to electric. They are not a fad. It's going to take maybe a while to get there, but to say it is a fad. And then what's the alternative then? If there was something else underneath, if you could say, well, nuclear power is going to be the way, and that's going to replace EVs, I don't see that happening. There's some talk of hydrogen, and even Toyota is working on an internal combustion engine that utilizes hydrogen. But these are so experimental. There's just nothing coming in underneath. We have a climate crisis. That's undisputable, right? The degree to which that is it 12 years or is it 100 years? I don't know. But most people agree that there is a crisis and we need to solve this. And EVs are a way of solving it.
I recently read some report that said that I think it was around 65% of people surveyed actually said that they do intend to purchase an EV sometime in the not too distant future.
It's higher. It's 80%.
80. Okay.
Yeah, that was a recent Angus Reid poll, and they're at various levels. There are the early adopters. They're ready right now, and then there's what you call the early majority, and that's sort of where we're breaking into right now. There's the late majority, and then there's the hardcore skeptics. And the skeptics, the people say, I will never buy one, are fewer and far between. They're only about 20%. Now the early adopters, they've already come in. They have their vehicle. The early majority, one of the biggest problems with them is finding the vehicles right now, and that's really limiting the growth somewhat. But
here's one of the popular ones by the naysayers. Used EV batteries will all end up in landfill because they're not recyclable.
Oh, completely false. They are not ending up in landfills, they're worth too much. Batteries are the most expensive component of a vehicle. So when recyclers get them, they have a high yield. There are concerns with much older batteries, and this can be a concern when battery chemistries change, because it's rendering something that's 20 years obsolete. Um, and because cars have such a long life, a car made today, well, it doesn't mean that that technology is even going to be viable in 20 years. So, so there is some concerns with the older battery chemistries. Um, they're not ending up in landfill, but we do need to sharpen up our recycling processes, and there are challenges with that. And the government is responding. There are models such as extended producer responsibility programs, or there's other voluntary programs that manufacturers can engage in to take back those batteries. But yeah, they're not ending up in landfills at all.
Yeah, and the industry is adapting. As part of the EV-friendly auto recycler training, does deal with this, how to properly store them,
how to store them, and how to and they're responsible as well. Industry is much more responsible environmentally than it was 30 years ago. BC was actually champions in the environmental responsibility. BC was one of the first in North America to come out and start regulating and licensing automotive recyclers. And even if they had the choice now, and you asked, would you go back to what you were doing 30 years ago if they got rid of the regulation? No. They're just it's just inset in their minds now.
And there are, besides recycling, there's a second life uses for batteries. There's industries coming up that are making use of batteries for repurposing them.
Yeah,
they can still store energy, just not enough for an EV.
Well, there's a high demand, and it's probably in one of your questions about the second life battery. So when a recycler ends up with a battery, there's a number of things that they can do with it, and it depends on what the state of health of that battery is at that time. It could just be reused in another vehicle. If it's a newer battery and it's got a high state of health, it could just simply swap one out and replace it, just like you would any other part. There's the repair, where a mechanic can, because a battery is made up of individual modules, and within each module there can be hundreds of cells. Well, maybe it's just one module that's bad. So all they have to do is swap out that one module. And then the big thing, and we'll probably touch on that, is the second life battery storage. You probably have a question about that, so I won't go too much into that, but that's another use. And recycling is the very final last thing that you will do.
So here's two questions that are similar. EVs are not better for the environment, they're actually worse. And the rising demand for electricity caused by EV proliferation will actually increase global pollution.
Okay, those are actually two really good questions, and there is some truth in them. I'll have to break it. Let's just take the first one. EVs are a polluter or worse?
Like, well, I think what they allude to is that the production of them is more environmentally unfriendly to offset, which offsets what the gains are by the tailpipe emissions. I once read an article, this was quite a few years ago, that compared the overall environmental footprint of a Prius to a Hummer, back when they used to build Hummers. Okay. And they actually made the case that the Hummer was better for the environment because they didn't source the nickel in the nickel mines and then shipping the raw materials around it, everything else that's involved in the manufacturing process. So I think that's where they're coming from. They can't argue that the EV itself in its use is less environmentally friendly, but the production of it.
Okay, so that's, we have to unpack that, and there is some truth to that. So I'll sort of steel man that argument a little bit. So some of it has to do with the standards of which we measure CO2 output. Okay, and if you were just to put a box around a gas-powered and then a pure electric vehicle, just on that standard alone, the gas-powered is a greater polluter because you're just measuring what is coming out of that tailpipe. whatever gets contained in that box. And then the battery, there's no tailpipes. Hence, we call them zero emission, right? That doesn't mean that it doesn't have an environmental impact, and it does. Now, where that comes from is in the mining to make the battery, and in particular lithium. And you touched on it. It's the lithium mining, it's the transport of all these materials, everything that goes into manufacturing that battery. So an ICE vehicle right off the lot and its counterpart that's electric, the electric is going to have a higher CO2 if you consider everything, okay? But this is where you have to measure it in the long run. After 3, 4, 5, or 6 years, this is where the zero emission now starts to exceed the ICE vehicle. And in the long run, it's better, much, much, much better for the environment. But it's also why it's important to get into the right kind of vehicle, because we tend to overbuy, and some of this has to do with the range anxiety. We think we need higher battery capacity than what we really need. So if all you're really using that vehicle for is, well, I just, my work is 10 minutes away and I use it to go back and forth to work, maybe take the kids to school and do some grocery shopping, you don't need you don't need something where you don't need a Hummer to do that. You can get by with just a little smart car or something like that, right? So it's important that the consumer be educated and get in the right kind of vehicle so that we don't over manufacture things. And that is a big problem. But ultimately they are better for the environment. It also assumes as well that the energy being used to charge that battery is coming from petroleum, coal, or gas or anything like that. If it's coming from renewables, then its environmental benefits are not right from production, but 2 years, 3 years right after that.
So the green methods or the clean methods of producing the electricity, that was the other side of the question, was the amount of pollution created by producing enough electricity to charge EVs.
So what we have to do is switch off petroleum to renewables. We're fortunate in British Columbia here because we have an abundance of hydro. But as we move more into wind and solar, and probably nuclear as well. Nuclear has a bad rap and a dirty name, and there's a whole conversation on how much renewables we can actually do. But yes, if it's coming, if you're powering your vehicle from your home and you have solar panels, then that is much more environmentally beneficial.
I actually saw a picture of a Tesla with a wind turbine mounted on the hood, self-charging.
Okay, that's interesting.
Yeah. That was also on social media, probably not genuine.
A wind turbine attached. Well, I've seen people ask about solar panels on cars as well, and the main problem with that, and there were ideas that were touted around the 80s. Remember the solar car and stuff?
Oh yeah.
But it's just the area you need for a solar panel. It would take up a 4-lane highway.
Well, maybe someday it would be, because now they're getting much more power out of a smaller solar panel.
Everything gets
everything
smaller.
gets better, smaller, more efficient, better, more.
That's right.
Production.
Could be.
You hinted about the mining of lithium.
Yeah.
One of the common comments is that there's not enough lithium in the world to manufacture all the batteries that we'd need to convert the fleet to electric vehicles.
Well, with anything, yeah, there's a grain of truth in that. Just like there's a limited amount of oil, you're going to eventually run out, right? There's only so much lithium in the world that we can mine. I think recent estimates are probably put us at current mining processes about 70 years from now. That's a long time, 70 years of our current process of mining lithium. Once that runs out, then you turn to the sea. And there is an abundance of lithium in the oceans, huge amounts. Getting it is a problem, but that used to be with oil. So remember in the crisis in the late 70s and the 80s, we were going to run out of oil in 20 years, and that's because they were just drilling sort of that surface oil. They got much more sophisticated. They could drill much deeper and get into those hard to get areas. And it's going to be the same with lithium. But that's also assuming that lithium is going to be the material that we're going to be using in 30 years.
Exactly.
Not lithium is a useful material because its ability to release electrons, which of course increases the voltage in circuit and all that stuff. There's other materials. They're looking at sodium, just plain salt, as a replacement for lithium now, and there's abundance of that in the world. So I don't really see that as a concern.
There's one that I saw recently that I found interesting was it suggested that road taxes pay for road maintenance, or gas taxes, more specifically. So they said, imagine if all of a sudden all the vehicles were electric and nobody's buying gas anymore, the gas taxes that goes to maintain roads, where is the money going to come from to maintain roads?
So, yeah, that's a real loaded question. First off, if the government needs money, they're going to get it one way or the other. They don't have to rely. There's a wealth of means that they can tap into your wealth and take what they want, and I'm sure they will. And also road maintenance. Well, who's doing that? Is that federal, like highway construction? Is it provincial? Is it municipal? Fixing potholes. That's all road construction. So that's going on at various levels. And various levels of taxation as well. There's also different kinds of taxes on your gas as well. It's not just one tax. There's GST, there's PST, there's the carbon tax, there's other taxes. There's a whole slew of it. So it's not just one tax. And they'll just switch if once that pool dries up, they'll find another.
They always do.
They always do, yeah. They're not going to stop government from taxing you.
Where's the money going to come from? Right here in your pocket. Another big one that you hear a lot, the electrical grid cannot handle the demand for required to charge EVs.
Yeah.
So there's a lot of assumptions there in that one.
Yeah, so let's try to give this some validity, because I don't want to just dismiss these comments. So it assumes it's making an assumption. Let's say that everyone in the world, if we could snap our fingers, every car in the world, I think there's about 1 billion cars in the world, were to be electric. And that all those cars, everyone goes home at 5:30 and plugs it into their DC fast charger. Yeah, that's going to cause, obviously, a drain on an entire system, and you're going to get blackouts.
So would it be if everyone went home and turned on their electric dryer or their range to cook dinner?
We saw that in
air
California.
Conditioning in the hot, in the hot weather, causing brownouts. So
we just saw that.
We already
in
have
California.
demands on our system. Right?
Yeah, we just saw that. That doesn't stop technology. So when air conditioning came out, I think it was in the late 40s, 50s, when air conditioning, nobody talked about, it's going to cause the grid to collapse. That never happened. So first off, that scenario is unlikely. So it's going to be slow and gradual that we're going to, more and more people will switch to EVs. So we have to increase our total output. And we're doing so at about 4% a year. So if you measure what the output was in 1960 to what it is now, it's probably increased about 4% a year, right? So we're producing much more electricity to meet all those demands. And we're just finding new and innovative ways of doing that. Now, it has been estimated that once we hit that 100% all electric vehicles, no gas on the road, that will probably mean an increase of about 30% of the total hour energy output that we will need. So at 4% a year, it's not going to take that long to hit the 30%. And that's probably will exceed the actual growth of EVs. And then there's a second component to that as well, and this gets back into the battery storage. So it's often a case that you can produce lots of electricity at certain peak periods of time. And what you do with that excess electricity? Well, this is where the secondary battery storage comes in, and so that's going to even out the grid. So there's not there won't be those high demands placed on by plugging in your EV overnight. That's going to collapse the system, right? Because if the energy is, if it's from renewables, if the sun's not shining or the wind's not blowing, it relies on the backup battery storage, and that's why batteries are not going to end up in landfills, right? Because we can use them, remanufacture them, and then every household could have a backup battery storage, which is very, very likely. It's already happening. We're already seeing that. Tesla's invested heavily into their batteries, and other companies are starting to come up.
Yeah, and the other part of the assumptions that are being made is that everyone's going home and charging their vehicles at the same time. Most vehicles or most drivers, drive less than 50 kilometers a day, and the capacity of the average battery, let's say, is 200 kilometers. So you're not going to have to charge your vehicle every single day. You don't gas up your car if you have an ICE vehicle every day. When you fill up the tank, you're usually good for, depending on how far you drive, but say you use that 50 kilometers a day benchmark, you're going to get almost a week out of it, if not more.
Yeah.
So, people will be coming home and they might not need to charge their vehicle, at that particular, all at the same time. So, and every day. So, another common one is that EVs are dangerous because the batteries overheat and catch fire.
Well, they can. So the batteries can overheat and they can cause fire. That statement is true, um, but certainly no more than gas engines. In fact, considerably less. They're quite a bit safer than gasoline engines, which can ignite at a much higher rate. Then to say they're dangerous, well, fire in general, any fire can be dangerous. Um, but you're probably at a greater risk in driving your gas car of that catching fire than you are of an EV.
And EVs have the battery management system that includes regulating their temperatures.
Yeah,
So
so
the
they do
chances
come
of it,
equipped. They're all computer controlled, and they monitor whether it's getting too hot or getting too cold. Um, Accidents do happen. They don't explode. So a gasoline engine can explode on impact. You remember the old Pintos, right? You could get rear-ended, and that was always a big scare, especially if you had a Pinto. I think I remember having a Pinto.
oh, really?
Yeah, it's
And
always
you live to
spectacular.
tell us about it.
Yeah, that's right. Yeah, and they even those were rare, but they recalled a bunch, and they've had problems with certain batteries, like with the Chevy Bolt. Um, there was a problem with the individual cells. It was the tab that was, I think, it was interfering with the electrical symbol, and it was a simple fix. They just had to recall them all back and then remanufacture the batteries. So there's always an element of risk, but far less risk than with a gas engine. And there's also usually telltale signs because they just don't burst into flames. There's generally, it starts off with some smoke. It will be emitted, a hissing sound or anything like that. And if you are aware of that, pull over, call the fire department immediately.
Mm-hmm. So when we do hear of these EV battery fires, it's first of all rare, and secondly, we're hearing about it because it's sensationalism in the media. It's just not news if an ICE vehicle catches fire, because they do.
No, they do every day, but no, you don't hear about it. You don't read about it in the paper. You don't see it on Facebook because it's just not newsworthy. But if a Tesla catches fire, yeah, it's going to hit the front page.
Yeah, because they want to say, "Hey, see, there's proof."
That's right. That's right. Yeah.
Yeah. Another common misconception, or well, maybe there's some validity in it, is that EVs are more expensive than ICE vehicles. Now, that may be true if you're looking at just the price tag of a EV and a very similar model, from the same manufacturer, maybe. The EV is probably going to be a little more expensive. But if you look at the bigger picture.
Yeah, so the first thing is when you say something's expensive, that's always relative to what your pocketbook is, isn't it? You can either afford it or you can't. And then total cost of ownership is really, it's one factor, but is not the factor. If all we did was look at cost, we would all be driving 90 Honda Civics, wouldn't we? Right? But there's so many other factors that go into our purchase decision. So the upfront cost right now is, as you compare it to a similar like-kind model, is more expensive, and that's just due to the production costs. The manufacturers are opening their production lines. It's economies of scale. They can't make as many, and this is why we have the government subsidies now to bring them down. Now, in total cost, though, and if you just want to look at the cost, the total cost of ownership is actually considerably less for an EV. The upfront cost is more, but even if you calculate in with the depreciation and maintenance, and you look at over the span of a few years, that EV is going to be considerably cheaper. And they've done studies with us. So they've taken two like-kind models, one pure EV, another gas-powered, and they took it over a span of 8 years, measured, well, what has been the cost, total cost to drive that vehicle, and the EVs all came out ahead. Now, it didn't go beyond 8 years. It didn't take it to the 20-year mark or anything like that, but we could probably assume that similar trajectory.
Well, that was one of the other questions, was that EVs are more expensive to repair. And if you look at each individual repair bill, there may be some validity there because the parts may be a little more expensive. It depends on what they are. But the basic repairs and maintenance are pretty much the same. They have brakes, they have tires. You know, the maintenance is pretty much the same as a ICE vehicle. But if one of the electrical system components fails, yeah, they can be more expensive. Or, well, if you have to replace the battery, of course.
Yeah, I mean the parts are just going to be naturally a little more expensive. Again, it comes down to economies of scale, and there are some horror stories like with the batteries, for instance, where somebody posts a $22,000 bill of a battery for a Tesla. These are the outliers. Again, they're very rare. Tesla batteries are some of the best batteries in the world, and they can last up to about 20 years, or at least projected. They haven't even been around for that long. And they still require maintenance. It's a misconception that, well, you never have to take it into a shop. That's false. You actually have to be on top of it. But they don't require regular oil changes and things like that. So you have a lot of reduced expenses with that. So overall, they're just cheaper to maintain.
What about the argument that a lot of people will be put out of work if EVs proliferate?
That is a good question. Every new technology, you have winners and losers. Some people are going to lose, but you're also going to create a lot of jobs as well. And this technology is no different. And in the short term, and in some industries, it could actually create more jobs. And here's why: currently we have two technological streams that's in production. You have your traditional gas-powered vehicles that are still being manufactured, and given the lifespan of 12 years per vehicle, they're going to be around for a considerable amount of time. And then we have EVs and the follow-up, which is automation, and that's a completely different beast. And they require different skill sets and different training. So is that job going to split into two? So you now have two jobs, not one. Right, so it splits into two streams, which is probably more likely rather than taking that traditional mechanic and thinking that you're going to retrain him and he's going to become your all-purpose guy. And even in small shops, you're seeing if they have a staff of 4 or 5, you have that one tech, and he's the EV specialist because he's been specialty trained, right? So in a sense, it's going to, in the short term anyways, create more jobs because there's always the fear of automation. In every industry, it is going to eliminate some jobs, but it creates other jobs.
Well, there was a related question about, if you buy an EV, you're not going to be able to take it to your traditional local garage that you may be familiar with because they won't know how to fix it. But that is why the EV-friendly training program exists, right?
It is. One of our mission is to provide the tools, resources, and the training out to a lot of these independent shops because they're needed. We need them. But they've been operating under an infrastructure that's taken 100 years to build. And it wasn't always like that. There were no mechanics. There were no mechanical shops in the early 20th century. People used to get their cars fixed at bicycle shops. and that's where you took your car. And then we just started to see the proliferation of gas stations. And the gas station was where you went to, not just to fill up on gas, but to get your car repaired. They would have a tow truck and they would tow your car there. They would bang out the dents and they would even recycle. So it was your one-stop sort of shop. And then that just evolved. The technology became more specialized and it grew from there. Well, now we have a new technology and places are going to have to adapt. Otherwise, they're not going to be around.
Related to the concerns around range anxiety, a lot of people claim that there's not enough charging stations and that the time that it takes to charge an EV is way longer than it takes to fill up gas in an ICE vehicle. One of your former guests was on and he talked about that, said that people often ask him how long it takes him to charge his EV, and he says, about 15 seconds. And then he explains this, well, I just have to pull up into the garage and plug it in, and that's it, I'm done, which is a lot shorter than the time it takes to stand at the gas pump with your hand on the trigger of the nozzle.
Very, very true for him, because he owns a house and he has a garage and he has a luxury that he can just pull in and charge his vehicle overnight. And a lot of people don't have that. They're parking on the street. They're in a condo complex that is not outfitted with chargers. And so for them, it may take longer. It's getting much quicker. To fill up your car with gas is, 5 minutes? I mean, you pull up, you go in, you prepay, and you do whatever quick shopping you need, and then 5 minutes to fill up your tank, and you're in and out. It's very convenient. But the charging is getting much more convenient. That kind of charging will take a little bit of a lifestyle change. People report that it's not a big deal. And places are adapting. They're starting to put up coffee shops or white spots or restaurants, right? So you just have to plan things out a little better. Workplaces are now outfitting for their staff parking with chargers, whether it's just a level 2 or even in some cases DC fast charging. So that's just like charging at home. You drive it to work, you plug it in. At the end of the day, you've got a fully charged car, and so on. And so we're seeing a lot more of that. So it'll just become more and more convenient as we progress.
One of the comments is that if you do have an EV fire, you can forget about trying to put it out with water. You have to use a special fire extinguisher, and that the batteries burn at a much higher temperature.
So that is false. There is no special EV battery extinguisher. It's just the extinguisher that you use, I believe, is a Class D. But it's water. That's what puts out an EV fire, and it's copious amounts. I think it takes an estimated 10,000 liters to fully extinguish that fire, and it can burst into flames again as well after that. There's also a new technology called fire blankets, and it's deployed by fire departments that have them. They're quite expensive, but it's just like a blanket. You can just drape it over a burning EV vehicle, and within 30 seconds, that flame is completely extinguished. So no foam or no special extinguisher. And if your car happens to catch fire, don't bring out the garden hose or do any of that. Just call the fire department.
Yeah.
And stay away. Stay away and call the fire department.
Yeah. That's why we have insurance on them.
And that's why we have insurance. Yeah.
Here's one that kind of caught me a little by surprise, claiming that EVs are too heavy. And I guess they're relating to the fact that the batteries are heavy, but then again, they don't have the engine or transmission. So, and the way they're positioned, they lower the center of gravity. So there are actually some advantages in the fact, how the vehicles are laid out. So what do you say to that? I guess maybe they're thinking that, because of the weight of the battery, it requires more energy to propel the vehicle, which reduces the range. So it's kind of related to what we were already talking about. But about vehicle weight, what do you say to that?
Well, so it's true that they're heavier, and that has to do with the battery. So I'd probably say just off the bat, that's probably at this point in time more of a concern for the commercial usage of them. And one of the reasons for that is the weight caps that are on these big rigs, tractor trailers. I think in the US it's 80,000. It can't exceed 80,000 pounds. I don't know what the equivalent is in Canada, but probably the same. And so that is true, because they go much longer ranges and are operating, sometimes 24/7. They need much bigger batteries. That's going to increase their weight, which means, well, they have to take less cargo. So, but they're working on it. Tesla is working on it, and there's some other upstart companies trying to increase the efficiency of the rolling resistance, drag, things like that they're working on. So they'll eventually get there. And then in terms of passenger vehicles, you're right. Yeah, it all has to do with energy density. So a gallon of gasoline is the equivalent to 33.7 kilowatt hours, which is, I think, around the equivalent of some of the early Leaf batteries. And gasoline is a very efficient for energy density, because if you run out of gas, you take your jerry can and you can walk down to the gas station and fill it up, and it's not that heavy. You couldn't do that with your Nissan Leaf battery. Take it out and it's a 600-pound battery and drag it down. But the batteries are getting much more efficient because they're getting much more energy dense, and they get smaller and more efficient, and they can pack more power in there. I mean, it's no different than any other technology. Things get smaller, don't they? We've seen this time and time and time again. I'm thinking
brick cell phone.
Yeah, I'm thinking the old cell phones, the bricks, and they were probably 90% battery to begin with, and they were pretty heavy. They were called brick for a reason, because you could drop them or chuck them, and they were indestructible.
They weighed about as much as a brick,
and they weighed as much too. They looked pretty cool in the day, didn't they? I mean, when you had a brick. Well, maybe if you saw somebody with a brick now, you might laugh. But that got down to what we have now. EV batteries are going to be no different. So they're just going to weigh less. Plus, there's also, to get the weight down, there's a lot of other materials, lightweight materials like carbon fiber, aluminum, that manufacturers are switching to. So.
Okay, well, here's one that we hear about a lot in Canada in particular, and that is how EV batteries run and how efficient they are in colder weather. So, the claim that you will get less range and less power out of your battery when we're in the throes of winter. But that's kind of true of ICE vehicles too, isn't it? Because when you have reduced daylight hours and it's colder out, you're going to use your lights, your heater, your wipers, and all that kind of stuff. So is it really that much different with an electric vehicle?
So there is truth to that. And yes, in extreme cold weather, everything slows down. People slow down. You don't move as fast when you're cold. What do? You dress warmly. Just like in extreme heat, you shed clothing. And batteries are no different. They have battery management systems. They have heaters, and they also have coolers. What extreme cold weather will cause is a drain to heat the cabin. You say, well, that's true of ICE vehicles. Yes, it is, but that's wasted energy that you're using to heat the cabin, right? Whereas with EVs, it's a direct draw from the battery. So there are things you can do. There's heat pumps that you can purchase. A lot of EVs now just come equipped with that, but they better distribute the heat. You dress warmly. Use the seat warmers instead of the heater. But it can be, I think it's up to about, in extreme cold, you can get up to a 40% reduction in efficiency. So that it is a factor, but it's just like anything. I mean, you just have to work around it. And again, they're getting better and better and better. And as we can be able to, as batteries get more energy dense, they'll just overcome those obstacles.
The last one that we have here, and I don't really think this relates to EVs, although the person commenting was making it relate to EVs, and that is the information, the data that is collected by today's modern cars. They can track your movements and your whereabouts and your driving habits and a bunch of other things. So this is probably not specific to EVs, but with modern vehicle technology, the amount of information that it collects, it's almost they look at it obviously as like it's spying on you.
Yeah, it's a little conspiratory. I mean, who's spying on you? So Google right now, just your cell phone, if you enable it, on your maps. It tracks everywhere you go, every restaurant or store, or how long you've spent somewhere. Google knows that. I don't know where that information goes, loaded
Well,
on
it
some computer.
obviously goes to Facebook, because a moment later you'll see an ad for that very
Yeah,
product, you know.
it does.
I don't think
Yeah.
you have to actually go there. You can just be talking about it with somebody, and the next
Yeah,
thing you know,
there's this identity of you on some Facebook, Google algorithm. So that technology is already there. And as cars get more sophisticated, and as they will, and electric is sort of the first wave of that, they just start to become mobile cell phones. So it does bring up an interesting point. I don't think there's somebody sitting in a room who's really interested in Renee Young and wants to know his every movement. I mean, they probably just want to sell you products. So, but it does raise some very interesting questions about who owns that information, right, and who has the right to it. And that is a whole other topic. It also has some concerns as well. Is if you control that, can you erase all that information? It's very important when you sell a car, or if it comes right off, that you have the ability, no different than your cell phone. You can just wipe it clean.
right?
And we already see it happening. A car gets into an accident. We've had cases where, and this is with Tesla. Tesla gets into an accident. It immediately wires that information to Tesla, and it can be actually a real problem getting it. Authorities have had problems getting that information from Tesla because they need to investigate the accident. There was a recent case in BC just a few years ago. Tesla refused; they wouldn't relinquish that information. I think they eventually did. So it's being discussed. It's right to repair is one aspect of that. It's before government right now. There's a private members bill. It's a big topic. Yeah, but it's not. I just don't see it as a conspiratory thing.
Well, thank you very much for your insight into these concerns, Ken. It's been very enlightening. And if you enjoyed this podcast, be sure to check out the rest of the EV Friendly podcast series. It's available on YouTube. And if you don't have time to watch the entire video version, there's also an audio version that you can take with you. It's called EV Friendly on the Go. It's available on Spotify and other places where you might download your podcasts. So thank you for watching. Be sure to like and share if you do enjoy this series, and we'll see you next time on EV Friendly.